Hey everyone, this is Ram Prakash, and I'll be explaining the Blind Watchmaker app that I've built that helps us visualize how evolution actually works and how organisms are created from seemingly minuscule improvements over a huge period of time. Basically, the scientist Richard Dawkins created the concept and disproved the creator theory, which basically says that there is a creator who guides the development of a particular organism. But in Dawkins' theory, he proves that very tiny improvements in a particular organ of a organism over a huge period of time that basically gets mutated in each subsequent generation helps focus and fine tune the particular organ for its use case. So I've built the app using JavaScript, and this is deployed on one of the GitHub pages. So I'll basically walk you through how and what each of the steps is. So I'll add the links below. So this is the page where we can go to, and this is basically the subset of all the organisms that are currently live in the simulated world. So basically each of these have their own unique properties, and let's say this one has is blue in color, others are pink in color, green in color, red in color, and they are of different shapes and different angles. Now each of these parameters varies from one generation to the other. So let's say this has a parameter value that specifies this degree angle, and this has a sharper degree angle between the two subsequent nodes. Now all of these are fractals that get generated based on those parameters, and we have a couple of tweaking parameters. So this is how much mutation that actually happens in real life. This value will be extremely low, and each subsequent generation actually gets like a very tiny improvement. Just for visual clarity, I've kept it a bit on the higher side. So let's say we start with this. Now we basically, let's take the example of a human eye. Now the human eye is a very specialized and complex structure, but that evolved out of seemingly simple evolutions. So the first organism that might have had an eye could only differentiate between the light and dark in very specific situations. But now we can see different colors, different spectrums, and that is over a period of time. So similar to that, we basically need to define a end goal right now. So that we say let's take the color as a parameter, and will basically describe that the organisms that have a red color are more likely to survive, let's say, in an environment. This can be equivalent to a organism having better, let's say a giraffe having a higher neck length is more likely to survive than a giraffe with shorter length of head. So let's take one of these. Let's just take a random color. So let's say we have this pool of organisms that are blue in color. Now we have defined that red is the color that lets the organism survive a bit more. So out of all of these, we see that this particular organism is slightly on the red side. So it has mutated in such a way that it has, let's say, 0.01% more chance of survival from the environment. So we'll select this. Now when we click on this, basically the algorithms takes that as the parent for each of these children organisms that are currently live, and each of these children are slightly mutated from the parent. So if you see this, we are slightly shifting to a more surviving plethora of organisms that are there. So if, let's say, out of these, let's say this particular organism has the most chance of survival. So we'll select this. Now we can see that the organisms that are currently there are moving more towards the red spectrum, and they have higher chances. All of these have higher chances of survival. Now we see that this is the reddest of all of them, and now mostly all of the blue organism or the blue trait has died down from the population, and we are seeing more of a red colored population. So now if we select the reddest of these, now we have the entire organism that is fit for the current environment. So the current environment says that if an organism is red in color, it will have more chance of survival. So eventually, over a period of time, the organisms have evolved such that they have the best chance of survival. Now, similarly, if we take a different parameter, let's say we say that the angle, the main primary angle, if it's 90 degree or the organism is flat, then it has a better chance of survival. So if we check this particular organism is like more angled. So we'll select this. Now, out of all of these, I think this is like the most widespread, and then we basically get here. Now here the angle between these two is like almost 180 degrees, and that means that the organisms have a better chance of survival. I've basically changed the playing field so that the organisms evolve towards that particular trait. So that is basically how evolution works. So in essence, tiny changes over a huge period of time will result in really complex and really specific organisms that are very good at one particular thing, or very good at survival, let's say. So in real life, this is basically the hybrid mutation rate, you can say. So if you have it really high, this is just for like demonstration purposes. If you have it really high, the variation between the parent and the children is like extreme. In real life, it will be really slow. So in real life, the difference between an organism having better survival rate versus dying will be very slow, very little. So let's say if I select this, we can see that almost everything is similar, but there are like very tiny changes. So it will take a longer time for us to reach where, but this will better simulate how the real life works. So that's all I have for now. Thank you for watching.